good morning, everyone. I'm Jamie Lerner. I'm the Chief Executive at Quantum. I'm going to talk today about the cloud or large-scale hyperscaler use case of tape. The core difference is that this is not a backup use case. There is no backup software, and it doesn't do a nightly backup that wakes your robot up once a day and it moves around a little bit and goes back to sleep. These systems are a live file system. They're nearline storage. All they've done is ripped out the hard drive and put in a tape drive. But it is a file system. It is an object system that's running 24 hours a day, and it's doing I/O. And the customer of that is okay with that I/O being really slow as long as it's really cheap. About 5 years ago, we started talking to the cloud operators, and they had this idea that, hey, maybe tape could be a cheap way to build a cheap storage tier, and maybe we could back up some of our stuff in our primary tiers, place it down those lower tiers, and if we ever have a problem. And we started doing some experiments, and it took us less than 2 years to realize that we needed to sit down and do something different. The systems we had just weren't really relevant. And I'll walk you through what we started building that led to this 16 acres of equipment being shipped, or over 40 exabytes today, live in production. And now we're basically in a model where we custom design tape systems with the hyperscalers for their business model, because an off-the-shelf box does not work for them. The innovation started happening with, okay, if we need to totally change the vector on cost, right? Tape an enterprise tape product is not cheap enough. It's got to get drastically cheaper, and we got to be able to service it with like 3 to 4 FRUs and CRUs, right? Field replaceable parts. They got to have no tools, no training. You can replace the part. And we had to get to where we could just shove the system into a corner. Because tape doesn't need much cooling, doesn't use much power, you can stick it in a shed. Right? You do not need, data centers in the hyperscaler are the world's most expensive real estate. Why put tape in it? Why would you ever put a piece of tape in it? Tape doesn't need a raised floor, doesn't need that heavy power, doesn't need that air conditioning. Stick it in a container truck. Stick it in a shed, pour a concrete pad and chuck it in there. So we started looking at, okay, how do we design tape libraries for that kind of a use case where you can't get to the front and back of it. There is no hot and cold aisle. You're going to respirate hot and cold air out one side. We just had to completely change what these things look like. We also had to totally change our software. If you want to go to a totally non-redundant, super cheap library, you got to fail over. Now, the biggest issue with erasure coding is a way to go. We all know that. But the issue is if you erasure code an object across 2 tapes, it is so slow, it is almost useless. So we had to invent 2-dimensional erasure coding where we never break an object across tapes. So you could always mount a file or an object by mounting 1 tape. Well, that took us building very different software. We ended up buying an object storage company and redesigning the guts of that object storage system to work with tape robotics, tape drives, and just the way tape works. And now we're able to do very high-end geo-spreading erasure coding with no performance hits. And again, we had to do that with our hyperscalers. So what this led to is we've been serving 5 of the top 5 hyperscalers, again, 40 exabytes, 3 million tapes in that deployment. So to give you a sense of scale, the tape could go to the moon and back three times. So the hardware is different. The first thing is it's got to be brain dead, just totally brain dead to service. So basically our systems now have 3 buttons on them. You press a button and the robot gets spit on the floor. It's part of the work we're doing with the hyperscalers is to say, look, we've got to just make this very, very easy on the software stack, very easy on the hardware stack. We've even added things. A lot of our hyperscale customers are worried about their data being stolen by nation states, hackers, ransomware. So we've begun, actually all of our systems are now shipping where you can write the data to a tape and then you can put a locking bar on that tape. So if the entire system is administratively taken over by a hacker, where they've just completely taken control of it, they can never gain access to that tape unless they actually physically break into the data center. And so now what we've done is taken all those learnings and packaged them for what we're calling the everyman. So you can buy a 0.5 petabyte system now that has all of this in it. Has the predictive analytics, has the same erasure coding that you would see in these data centers, has the S3 interfaces, has a NAS interface. So you can do a file and object presentation tier to a tape stack. You can also do the full tiering like you would see in a cloud, where you can store data on NVMe, disk, and tape. A lot of times you store them in all three, and you charge different prices for which one you want to pull it back from. And you know, those are learnings that we've packaged into shipping product, all with the goal of just making tape easier to consume. And for a lot of our enterprise customers now, they don't even necessarily know or ever see tape because they never touch tape. They just receive a big, large rack, they plug it in, and that rack presents, you know, 14 to 20 petabytes. They line up the racks, and all they see is they plug Ethernet and power into it, and they talk S3 to it, and it runs. And that has been how we've been able to get a lot of people who just said, you know, tape's kind of a 4-letter word, and I get why. I mean, you know, 4 years ago, I didn't really even know what tape was. We've been able to get a lot of customers to say, look, if you can give me this cost equation at this ease of use, I'll buy that.